right, so we're looking at page 41. So on Friday, we combined functions by adding, subtracting, multiplying, and dividing. Today, we are going to compose them with composition of functions. So it says another method to combine functions is called composition. Given f of x and g of x, the composite function, you read this as f of g of x, is defined as f of g of x. Kind of looks like fog, but that's not really an O, and it's not really that big. But it's not the dot like the multiplication was. It's open, so you've got to make sure you're paying attention to how that's written. It could also be written as f of g of x, like so. So you can compose them all day long, but if you don't understand the domain and how that works, that's going to be a little bit of a problem. So, and this wording can be kind of confusing, and you can, just really can get lost in what it's trying to say. So let's break this down a little bit. It says the domain of the composite function f of g of x is the domain of g such that g of x is in the domain of f. So let's think about the pieces that we're talking about. Domain of g, is this referring to x values or y values? X values, right? Such that g of x, does that represent x values or y values? Y values. Oh, that looks like an x though. Well, that's the other thing. Sometimes y'all's handwriting gets a little crazy, and I know I'm one to talk because my handwriting is terrible, but sometimes it's hard to tell if you mean an x or a y, so you better be careful with that because I'm going to go with whatever it looks like, and a lot of times your y's look like x's. All right, such that g of x, which is y values, is in the domain of f, and domain of f is talking about which values? X. Okay? So we'll look at that a little more carefully when we get to one of these, but you got to think about what that means. We're talking about inputs, outputs that then become inputs, right? And so you got to be able to wrap your mind around what those different values are representing. So let's look at example 1. F of x. What's the domain of f of x? All real numbers, right? What's the domain of g of x? All real numbers. Okay. So now let's find f of g of x, which this could mean f of g of x, you can write it like that, which is the same as f of g of x, which is x squared minus 4. So basically we're substituting x squared minus 4 in for all of the x values in f of x. So that's going to be x squared minus 4, substitute that in, and then plus 7. So f of g of x is equal to what? X squared plus 3. And then we have to look at the domain. So let's think about what this means again. This says the domain of f of g of x is the domain of g. So it's the domain of the input part, this right here. The domain of g, which is all real numbers. Such that g of x, all of the outputs of this, all of the y values live in this domain. Well, the domain here is all real numbers. What's the range of this? To infinity, right? Does that range live inside of all? It does. So my domain is the domain of g of x. It's not -4 to infinity. It's saying that this is my domain as long as all the outputs I get actually live in this domain, which they do. So my domain is just all real numbers. Okay. You cannot just look at the end product and assume that you can find it that way, right? Because sometimes things cancel out. All right, so then I'm going to find g of f of x. So g of f of x is going to equal g of x plus 7. So that means I get x plus 7 squared minus 4. Right. Is x plus 7 squared x squared plus 49? No. I promise you, if you do that on a problem, you're getting no partial credit from me. None. I'm done. I may even give you 0 for the whole side of the paper because we should be way far past that. This is x squared plus 14x plus 49 minus 4. That means that g of f of x is equal to x squared plus 14x plus 45. So then I go and investigate my domain. All right, so my domain is the input part of f. So my domain would be the domain of f such that all the f of x values live in this domain. Well, what is the range of this function? All real numbers. Does all real numbers live in all real numbers? Yeah, so it's all real numbers. When they're both all real numbers, it's always going to be that. But that's how we have to look at it, because it's not going to work out like that on every single one of them. Okay, everybody good so far? All right, so what's the domain of f of x here? All real numbers. What's the domain here? X such that x can't be what? Negative 1. Good. Okay, there's that domain. All right, so we've got those, so let's go find our compositions here. This is going to be f of g of x, which is f of x over x plus 1, which will give me 3 minus x over x plus 1. What do I have to get here? Common denominators. Okay, so my common denominator is x plus 1, so this will be 3 times x plus 1 over x plus 1 equals, oh, not equals, I'm sorry, dang it, minus x over x plus 1. Can I cancel out these x plus 1s? Yeah, but I just put them there, so don't do that. That's where you get in a vicious circle of stuff, right? Oh, look, I can simplify. No, you just put them there for a reason. So your denominator then is going to be x plus 1, and then you get 3x plus 3 minus x will give you 2x plus 3. Can I reduce that? Nope, I can't cancel those x's out? No. All right, so that is equal to f of g of x. Okay. Then I got to look at my domain. All right, so the domain is the domain of the input, which is g, such that all of the outputs, g of x, lives in all real numbers. So all of the outputs, is there any possible way to get something out of here that's not a real number? No. So whatever the range is, it doesn't even matter if we actually write it down. The range, everything that comes out is all real numbers, which means that this is my domain. It's the domain of g, so it is x such that x cannot equal negative 1. There you go. So then we move on to g of f of x. So g of f of x will equal g of 3 minus x. So that gives me 3 minus x over 3 minus x plus 1. So that leaves me with 3 minus x over what? 4 minus x. And that is equal to g of f of x. Then I have to look at the domain. The domain is the domain of the input, f, which happens to be all real numbers, such that all of the f of x values live in g of x. Well, what's the range here? All real numbers. Do all real numbers live in this? No, they don't. So what's happening here is that when I substitute this in, this becomes my x value, right? And we're saying that x cannot equal negative 1. That means that f of x, because that becomes my input, cannot equal negative 1, right? Those y values that I get out, none of them can be negative 1, because then that becomes a problem for me. Everybody with me? F of x is 3 minus x. So 3 minus x cannot equal negative 1. So what can x not equal? Okay. So that means that my domain is not just the domain of f. It can't be all real numbers. It's all real numbers except for anything that would cause this y value not to live in this domain. And so when this y value, it can't be negative 1, this is what I get from this. Therefore, my domain is x such that x cannot equal 4, which is what we would get if from this final product anyway, but remember, it doesn't always look the same because things could cancel out and you could miss something out of there, depending on the situation. All right, everybody okay with that? We good? You have to actually think. You don't get to just sit down and do a bunch of math and get an answer. Like, you have to think through the process and what's happening. All right, let's look at example 3. What's this domain? All real numbers. What's this domain? All real numbers. That's great news, because when they're both all real numbers, the domain answers all real numbers. Okay, so we still have to work it out. Oh, goodness. All right, so f of g of x is equal to f of 4x plus 1. So that's equal to 9 minus 2 times 4x plus 1 cubed. All right, so I'll give you a minute to work that out. Oh, shoot. All right, that's what you should get. And that should not be a great source of stress or confusion for you. Watch your signs. They will mean disaster for you if you're not careful, but you got to be able to cube a binomial. Not only do you need to square one, you need to be able to cube one and know how to handle that. All right, so what's my domain here then? All real numbers, right? Because outputs are all real numbers, live in all real numbers, we're good. All right, so g of f of x equals g of 9 minus 2x cubed. So that's equal to 4 times 9 minus 2x cubed plus 1. So that gives me 36 minus 8x cubed plus 1. So g of f of x is equal to negative 8x cubed plus 37. What's my domain? All real numbers. Okay. We all good? Any questions? Yes, ma'am. You don't have to factor it out. You just leave it. I mean, you don't need to do extra stuff. Yeah. All right. Next part. Alrighty, so f of x. When asked about the domain last period, I got all kinds of crazy things. So let's think about how we find that algebraically. What has to be true about what's under the square root? It has to be positive, right? Or 0? Yes? So whatever's underneath here, x plus 5, has to be greater than or equal to 0. We all agree with that? Which means that x has to be greater than or equal to negative 5. Another way to look at this is a square root function. This is the parent function, right? So this is a transformation of what? Left 5, right? So it would look like this. And this is here at negative 5. See how when you look at your graph, all of your x values are greater than or equal to negative 5, right? You need to understand it graphically and algebraically and tabularly in all different ways. But my domain here, x has to be greater than or equal to negative 5. What's the domain of g of x? All real numbers. Okay. So I'm going to go find f of g of x. So f of x squared would be equal to the square root of x squared plus 5. Can I cancel out that squared, make it x plus the square root of 5? No. This is equal to f of g of x. Can't do anything else with it. Then I got to look at the domain. The domain is the domain of the input such that, so the domain of g, which is all real numbers, such that all of the g of x values live in this domain. So the g of x values, meaning the range, what's the range of this function? No. 0 to infinity, right? Because this would be a parabola. Bam. Right? So my range there is from 0 to infinity. Does 0 to infinity live in this domain? Yes, it does, right? If x has to be greater than or equal to negative 5, 0 to infinity is greater than or equal to negative 5. Does that make sense to you? Okay, because these y values become these new x values. So since these g of x values all live inside of here, then I'm good, and my domain is all real numbers. So then I find g of f of x. So g of f of x equals g of the square root of x plus 5. So I substitute that in, and I get the square root of x plus 5 squared. What's the square root of x plus 5 squared? X plus 5. So this is x plus 5, but that is g of f of x. Oops, I don't guess I want to box that yet. So is my domain just automatically all real numbers? No, I have to go back and look at f. The domain here is the domain of f such that all of the f of x values live in all real numbers, right? Well, all of the outputs that we get, would they all be real numbers? Yes. So the domain is the domain of f as long as all of the f of x values live in here, which they do. So my domain is x is greater than or equal to negative 5. If you wait until the end to get your domain, you may not be right because it's not all real numbers, which is what this looks like here. You have to know how to look at what's your input, what's your output, what the pieces are. Okay, we good? Yes? Okay, and composition of functions is not new either. All right, so let's look at example 5. We got f of g of x. So f of g of x is equal to f of the cube root of x plus 4. All right, so you go ahead and finish that one up. Did you get x plus 3? What do you think the domain is? All real numbers. Why? Because this gives you all real numbers? No. What's this domain? All real numbers. And what's this one? All real numbers. So our outputs are going to be all real numbers. They'll live in there. Everything is great. Okay, good. So our domain, all real numbers. All right, so then we do g of f of x, which is g of x cubed minus 1. So finish that one up. Can I go ahead and take the cube root of that x cubed? No. Okay, so can I do anything else here? No. That is g of f of x. And what's my domain? All real numbers. Good. Any questions at this point? Okay. So now we're going to evaluate each function. Right? So f of g of 3 is f of g of 3, like this. So that's equal to f of, well, g of 3 is 3 plus 1. So that's f of 4. And that's equal to the absolute value of negative 2 times 4. So f of g of 3 equals what? 8. Good. Everybody okay with that? Yes? All right, you find g of f of negative 5. I'll write at the same time you are, but don't just copy mine down. All right, did you get 11? Yes. Any questions? Okay. So then do f of g of 9. Do a and b on 7. I'll give you a couple minutes to get both of those done. All right, so I've got them both started. Now they're going to help me finish them. Did we all at least get to f of the square root of 5 equals what I have written down right here? Okay, which means that then that f of g of 9, once I simplify this out, what do I get? 25, 5 plus 5 square root of 5. There you go. All right, so g of f of 7. F of 7 gives me 7 squared plus 5 times 7. So that's 49 plus 35. What does that give me? What's 84? Good. So that gives me the square root of 84 minus 4, which is square root of 80. All right, is that a square? No. Do I reach for a calculator? No. Do I leave it like this? No. So g of f of 7 is equal to what? 4 square root of 5. Boom. There you go. Okay. Everybody good? Any questions? All right. So let's look at how we decompose functions, which means we're going the other way, which is a lot easier than it looks or than it sounds. It says find two functions f and g such that f of g of x equals h of x. Okay, so it's easiest to work from the inside out. This is f of g of x, which means g gets substituted into f, right? So if we find our g of x values first, that will help us, and then we can figure out what the f of x value would be. So I'm looking for two functions, one that could get substituted into the other. So if I work from the inside out, the inside part here is 1 minus 2x, right? So I'm going to make that my g of x, 1 minus 2x. If that is g of x, what would f of x have to be? X cubed. Okay, because then I just take this, substitute it into x cubed. That's what I get right there. You saw it's just the opposite of what we've been doing? We're just taking them apart. That's why it says decomposing instead of compositions, the decomposition. Okay, so let's look at 9. What do you think g of x would be? X squared plus 1, good. Which means f of x would have to be cube root of x. So see if you can come up with what goes in 9 and 10. I'm sorry, 10 and 11. All right, who wants to give me a g of x value for 10? Not everybody at once. What is it? X plus 7, okay. So then your f of x would be what? Minus 1. Y'all agree with that? Yes? Okay, good deal. All right, somebody else help me with 11. Who wants to help me? Okay, g of x is x plus 5, which means f of x would be? Good. All right. Any questions? We all good? Yes? Awesome.